All right, guys. Good morning. Let's wait a few minutes to start the review because it looks like not only 10 people are signed on right now. Um, just put some things in the chat. So today this morning we'll do a practice exam for midterm 2. And then also if you missed any of the assignments that we've done since spring break, we're gonna start the last period of the class after midterm 2. And so if you need to turn anything late or have any assignments that are not submitted yet, you got to get those in by the midterm due date of April 27th because we're doing new material. I'm going to post the solutions for the exams and all the assignments. Okay, so let's give it a few more minutes for people to log in. But the practice exam we're going to go over today is right here on Blackboard under midterm 2 spring 2020. So there's an older exam with all of my solutions that we're going to go over today. Okay, so any general questions about anything right now? All right, so let me write a few more things in the chat about the midterm coming up, and then we'll start the review in a few minutes. Okay, so the things that I wrote up here in the chat for this morning, just to remind you, all the due dates are on the updated syllabus on Blackboard. But so we've reached the point of finishing up the second third of the class, and so no new material until the midterm is done, and then we'll start new stuff after that. They'll be on the final exam. And so again, today we're going to do a practice exam. Monday I'm going to talk about or distribute the midterm 2, and that's going to be due. You have a week to do it. It shouldn't take you too long, but just to give you some time. And then if you've missed any assignments since the spring break, you can still do them up to the due date of the midterm of the 27th. And so just post those to the discussion forum if you haven't done so already. Most of you have. But yeah, save a few more days to do that. And then I'll distribute midterm 2 next Monday. And you'll submit it via email because I don't want everyone to see the discussion forums of your answer sheets for the midterm. And if you can scan a PDF or make a PDF of your answer sheet, or do a Word document, that'd be preferred. So it's a little bit easier to grade. If you can't do either of those things, you can just take a picture of your work. So PDF or Word format is preferred for the answer sheet for the midterm, but just work with what you can. Okay, so let's go over the practice exam for the midterm. And so if you go to on Blackboard, I made a section called Midterm 2 Spring 2020. Go there, and there's just I'll put the midterm there on Monday, next Monday. But if you go there now, you'll see that I solved the practice midterm, and this will be kind of our review for the midterm. All right, so for midterm 2, this is the last one I wrote in fall 2019, and so the one that's going to be coming up on Monday, which will obviously be a take-home exam, is going to be very similar to this. And so we'll go through this one as an example, and then you'll get a different version for your midterm 2 that's formatted like this. There's kind of 2 big questions, and then you should know how to solve it if you can do this one. You can you'll have this one as an example to work with. Okay, and obviously since everything is a take-home now, you can use notes or computers or the textbook if you have it, because everything is done at home now. Okay, and so the first problem, this 50 points, there's 2 big 50-point questions on midterm 2. And so this is we've had some practice with this one. We did an exercise and then additional problems that were the drug production one that you guys did. There's like 5 extra problems that give you practice for this one. So you should be familiar with this concept, but it's going to be tested on midterm 2. And so you'll do a screen cap of the drug production question. Okay, and then also a screen cap of the sensitivity report, because there's a question on the shadow price of one of the things, and so that goes along with the drug production one. Okay, so question A is refer to the screen caps of the drug production problem or model, and assuming no changes, which drug is sold exclusively? Okay, so you guys have done this before as a practice problem, so just look up at the screen cap. And remember that there's only one factor in the production process, and you can see that currently the only drug that's being sold is drug A. And so drug A is the drug that's currently being sold. The other 2 drugs, B and C, nothing is being sold at the moment. Okay, so drug A is sold exclusively, and the revenue per labor hour concept explains that. Okay, and then since you know that the drug A currently has the highest revenue per labor hour, you should go ahead and calculate the revenue per labor hour for drug A. So revenue per labor hour, just in general, is calculated by the drug selling price divided by the labor hours to make that specific drug. Okay, so let's just plug in, since we know that drug A has the highest revenue per labor hour, let's plug in to figure it out its selling price and the hours it takes to make it, because it must be yielding the highest revenue per labor hour. Okay, so drug A's selling price is 200. All right, and so that's the current selling price, and then the labor hours it takes to make it. That's 2 hours, because you can see right there that in the drug A part, it only takes 2 hours to make drug A. So the selling price is 2. So the selling price is 200, and it takes 2 hours to make it. So if you divide 200 by 2, that gives you a revenue per labor hour of $100 per hour. Okay, so $100 per hour means $100 $100 per hour is currently the leader in revenue per labor hour. And so we got to figure out what the selling price of the other drugs have to rise to be comparable or better than drug A. All right, so part B is drug B's price needs to be greater than or equal to what for only drug B to be sold? Because right now drug B is not being sold. Okay, so drug B's. Let's start with the general definition of revenue per labor hour, and then figure that out for drug B and make it equivalent to $100 per hour. Okay, so revenue per labor hour is just the selling price divided by labor hours to make it. And we know that the revenue per labor hour for drug B has to come up to 100. Otherwise, it wouldn't be comparable and it wouldn't be sold. So let's plug in the hours. Or we're trying to figure out the price divided by the hours to come out to 100. And so it's the drug B price divided by how many hours it takes to make it. Okay, if you look up at the chart or the inputs, you can see that drug B takes one drug A to make. Okay, and that we know that one drug A takes 2 hours, and then you can see it takes 4 additional hours to make it into drug B. So the total hours for drug B are the 2 hours for drug A plus 4 more hours. So 2 plus 4 is 6 hours to make each drug B. So it's 6 hours. Okay, so we know that sum price divided by 6 has to come out to $100 per hour. Okay, and you can probably see that either 6 times 100 is 600, or another way of saying it is what divided by 6 is 100. So we know that 600 divided by 6 is 100, and so the drug B price has to come up. See, the original price was 500. That's not high enough to be comparable with drug A, given the hours to make it. So drug B's price has to go up to $600 for that to be sold. Okay, so the revenue per labor hour is 600 divided by 6. It gives us that $100 per hour we're looking for. And so the answer to the question is B's price needs to be greater than or equal to 600 for only B to be sold. Okay, what about drug C? So C's price needs to be greater than or equal to what for only C to be sold? All right, so you want to figure out the revenue per labor hour, just starting with the general equation of the selling price divided by the labor hours to make that drug. Okay, and we're trying to find the price. So what divided by the hours gives us the $100 per hour we're looking for. So the only thing we're doing here in this step is adding up the hours it takes to make drug C. Okay, and you can see that it's 24 hours, and let me show you why. If you look at the inputs chart in the screen cap, all right, so you basically need one drug B, you need one drug A, and then you need 16 more hours to make it drug C. All right, so it's just a big addition game here. So we know that it takes 6 hours to make drug B, right? So that's a 6. Sorry, I just got some pop-up added. Okay, so it takes 6 hours to make drug B, so that's a 6. It takes 2 hours to make drug A, right, so that's a 2. Okay, and then you gotta add everything together. So it's 6 plus 2 plus 16, and so if you add all those together, that comes out to 24 hours to make drug C, right? So 6 hours for drug B, plus 2 hours for drug A, plus 16 more hours, that comes out to 24 hours to make drug C. Alright, so now it's just basically what divided by 24 is 100, and we can figure that out. That the price of 2,400 or 2,400 divided by 100 exactly gives us that $100 per hour we're looking for to be comparable with drug A. Okay, so the answer here is drug C's selling price has to be greater than or equal to 2,400 for only C to be sold. Okay, so we did some homework problems for that, or some assignment problems for that type of problem. Any more questions on what we're doing here for the revenue per labor hour steps and trying to figure out what's comparable? Okay, and so for this one, Okay, so most of you have done this from a few weeks ago, the assignment for the drug production. But if you haven't done that, make sure you do that, and that'll give you practice for this one. So if you need more practice, and you haven't done the drug assignment production question or the assignment, then make sure you go through that, because that'll give you plenty of practice that you'll need to do this one. But I think most of you already done it. All right, then we're still on number one. Part D is given the current parameters, let's just calculate the objectives. All right, so currently we know that only one of the drugs is being sold, and the only way this firm is making money is by selling the drugs, and so the revenue they make is just the selling price of the drugs times the units sold. So it's just like price times quantity for any revenue situation. It's how much you're selling times the price of that good on the market. So we're only selling one product right now, which is drug A, and its price is $200. Okay, so in general, the revenue is the unit selling prices times the quantity sold. Okay, so the revenue is unit selling price times the units sold. All right, so all we got to do is plug in the selling price of the drugs that are being sold and the amount that's being sold. So it's just price times quantity. Okay, and drug A's selling price is $200, and the company is selling $5,000. So that's the revenue for drug A. Okay, 200 times 5,000, which is $1 million. And you can look up at the change out, but you see that you already know that no other drugs are being sold right now. And so it's the only revenue the company is currently getting is that from selling drug A. So look up and see that, just to confirm that drug B and drug C are not being sold. Okay. Since those are not being sold, they're not going to be part of the revenue. So the revenue is just really the one drug that's being sold. And so it's just the price of that good times the amount sold. So price times quantity, or the unit selling price times the unit sold. Okay, so our revenue is $1 million exactly. All right, part E, let's first list each constraint. All right, so if you look at the screen cap, anything that has an inequality next to it is going to be some kind of constraint. And there's really only two in this one. Okay, so you see right there, the units produced have to be greater than or equal to the units used in production. So the first constraint is units produced is greater than or equal to units used in production. So that applies for all the drugs. Okay, and the only other constraint is the labor hour constraint, because we're limited by the number of labor hours we can use manufacturing these drugs. So the hours used is got to be less than or equal to the hours available. So those are the two constraints that you'll list right there. All right, so units used in production greater than or equal to, units produced has to be greater than or equal to units used in production, because obviously if you don't produce it, you can't use it. Yeah. hours used for labor less than or equal to hours available. Now the other part of this question is just to write, we listed the constraint. And the second part is the labor hour constraint, binding and non-binding. All right, so you remember this part from a few weeks back. Okay, so look at the numbers. Remember, if you use all of the resource, if you use all the constraint you're allowed on the right side, then it's binding. If you don't use it all, then it's non-binding. Now you can see here that we had 10,000 hours available. We used all 10,000, so therefore it's binding because we used everything we could, and so there's no slack, and that constraint is binding because we used the whole 10,000. So there's no difference between the left side and the right side. Okay, and then calculate any slack for the labor hour constraint only. Okay, and the labor hour constraint is binding, like we just said. The company used the whole 10,000. And if it's binding, there can't be any slack because the slack is the difference between the right side and the left side of the constraint. So the labor hour constraint is binding, which automatically means there's no slack. Okay, and the units produced, here's equal to the units used in production. That one, so the question is specifically asks you just to do the labor constraint for the binding and the slack. And that's because this one doesn't really have an interpretation the same way. And so for the first constraint, for the units used in production one, you can just put an NA for the binding and the slack question, or just leave it blank. So I just put a little NA for not applicable. And so the binding part and the slack part is only going to ask you for the labor hour constraint. All right, then finally, let's answer question F about the shadow price of the labor hour constraint. So let's interpret the shadow price for the labor constraint in range B23 to D23. Okay, so you'll get a screen cap of the sensitivity report, and all you need to look at in this entire report is the shadow price for the labor hour constraint. So look for the shadow prices. Okay, and the one you see in B23 for the hours used, which shows you that you should recognize the 10,000 and 10,000 from the Excel screen cap. Okay, so the hours used, the B23 hours used labor hour constraint is the only one you need for the shadow price. So you're interpreting this 100 right there. Okay, so you want that at 100. All right. So the shadow price is 100. From the sensitivity report, the shadow price is equal to 100. Okay, and so you're asked just to interpret that one specific shadow price for the labor hour constraint. So what does that shadow price mean? So remember that's the effect of getting one more units of the right side, and the shadow price is the effect on the objective. So the right side is labor hours used in production, and it's going to affect the revenue for this firm. So basically just interpret it like we've been doing. Okay, so if the drug company gets one more labor hour and uses it in production, then the shadow price is the effect on the objective. So if that happens, then revenue from sales will increase by $100, which is exactly the shadow price. Okay. So question one is going to be that big question on the drug production question. So it'll be similar to this one where you do the you do the revenue per labor hour analysis like we did in the practice for the assignment for drug production. Then you're going to calculate the objective, and then you're going to do the list of constraints, do that part, and then lastly just interpret the shadow price. So all stuff we've done before, but okay, if any questions on this question or any of the parts for number one, the drug production question? Okay, so can you go back to constraint one? Sure. Okay, this one? How did I get it? Okay, so yeah, you're listing the constraints here that the solver has to go around to figure out the solution, right? And so remember, we're trying to maximize revenue by choosing how much drug to produce, and we're constrained by the things where you see the inequalities. So we have two areas of constraints. Okay, so one of them was the labor hour constraint, which I think you're familiar with. Okay, and this one is right here. So just see how for each of the drugs, the units produced in these three cells have to be greater or equal to the units used in production for each drug. So we're just simplifying and saying that the units produced for drug A, drug B, and drug C have to be greater than or equal to the units used in production for each of the drugs. So you're just describing this constraint right there. Okay? Okay, you're welcome. All right, so anything else on number one before we go over question two? All right, so question two is on the last one we did on, I believe, Monday. So example 14.1, which was on the forecasting best chips one. And so there's a nice question. We did some similar practice question on Monday. But here's another one. All right, so this is from example 14.1, which was the exponential growth model. Okay, and you'll be given the equation for the absolute percentage error, which you know is just the absolute value of the actual data minus the prediction, and then divided by the actual. So it's just the percent off of the prediction is from the actual data in absolute value terms, percent-wise. All right, so here's a little screencast of some historical data for the sales for the best chips. So there's the sales from years 1 to 10, and you're predicting 11 and 12. Okay, here are most of the predictions for the linear and the exponential, and then here are most of the absolute percentage errors. So I kind of made it so you see the empty boxes are what you're going to calculate. Alright, and there's a screen cap of the linear trend line with the associated equation that you're going to need. And there's a screen cap of the exponential trend line with the equation that you'll need to calculate that. Alright, so again, all the black dots are the actual data points, and we're trying to predict, extend the trend lines for 2 more years in the future for years 11 and 12. So this is extending the trend line for the linear, and this is extending the trend line for the exponential. So which one is a better predictor of the past data? And that's what we're going to figure out. Alright, part A is we create the screen cap of the exponential model, and using the linear model, let's calculate the APE for year 10. Okay, so this is the general equation, or what you know about the APE, and just plug in the actual data minus the prediction divided by the actual, and then put that in percent terms and get the absolute value. Okay, so you're calculating this blank box right here, and so the actual sales data in year 10 was 315. The prediction for the linear was 291. Alright, so all you're doing is actual minus predicted over actual, so it's 315 minus 291 divided by 315. Okay, so the APE for year 10 for the linear is 315 minus 291 divided by 315. And if you put that in percent terms and take the absolute value, right, if you get a negative, just take away the negative because you want the absolute value. You should get something like 7.6%. Okay, what about the exponential one? So part B is using the exponential model. Calculate the APE for year 10. Alright, so you're calculating that blank box right there. You want to know what that percent is. Alright, so these are both, this is APE, percentage error. Your answer's got to be at some percent. Okay, so the actual data, sales data for year 10 is the same as 315. The exponential prediction for year 10 was 317. So you're going to calculate the 315 minus 317 over 315. Actual minus prediction over actual. Okay, so APE, year 10 exponential is 315 minus 317 over 315. Okay, so just put that in percent terms, and I think this one comes out negative. So just remove the negative because you want the absolute value, and so it's 0.6%. It actually comes out to negative 0.6%, but absolute value terms, it's 0.6%. Alright, and then part C is which model predicted the sales data better in year 10? And all you have to do is evaluate which error is lower, which one had less error in modeling the actual data. So you know it's the exponential model because it has a lower error. So exponential because the absolute percentage error was 0.6 compared to the absolute percentage error of 7.6% for the linear. right? So it's just asking you which model captures the data point better in year 10. And you should, just by looking at the data points, you see that the actual was 315, the linear prediction was 291, and the exponential prediction was 317. So just knowing that 317 is a lot closer than 291. Okay, so parts A and B, make sure your answers are in percent. Parts B and E, your answers are going to be in dollars because you're predicting the sales. All right, so calculate part D, calculate predicted sales for year 12 using the linear trendline parameters that you have in the trendline screencast. All right, so start with that equation. Y is equal to sales. All right, Y is what you're explaining, and X is the time period or time. So it's the year. So your equation is going to be given Y equals 23.28 times X plus 58.02. So start with that, and then just plug in your X value for whatever year you're looking at. In this case, it's 12. Okay, so sales for year 12 using the linear model is equal to 58.02, that's the intercept, plus 23.28, that is the slope of the linear model. All right, and then times 12 because X is equal to the year or the time period. So just put in the 12 for year 12. So X is equal to whatever year it is in this model. So 1, 2, 3, 4, 5. In this case, you want sales in year 12. So in the 12th year, just put in 12. All right, and that your prediction comes out to 337.38 or something close to that. And just make sure your number is going to be somewhere in the range of what the other numbers are. All right, so we're getting like 100, 200, 300. So if your answer comes out to like, negative 500 or a million or something, then make sure it's something in the correct range. So it can't be something ridiculous. And so 300 or 200 sounds like a good predictor. Okay, part E is calculate predicted sales for year 12 using the exponential trendline parameter. So now just use the exponential equation, plug in the 12 for X, and do the calculation there for that prediction. Okay, so there's your equation. Y, which is sales, is equal to 86.43 times E raised to 0.15 times X. So that's all you're doing here is just putting in X, which is 12, for the year 12 prediction for the exponential. Okay, so sales for year 12 equal 86.43. That's one right there. All right, times E, the number E, and that's raised to 0.13 times 12. All right, so this is E raised to 0.13 times X. X is equal to 12 for year 12. Okay, and if you put that in your calculator, you get something like $411.30. Alright, and so again, that looks like it's in the right range. And so the absolute percentage errors, make sure those are in percent. And the sales prediction, those should be in dollars because you're predicting your actual data. And then last part F is what does the slope of the linear curve imply exactly in this model? Okay, so the slope of the linear curve is 23.28, and you can see that that is a constant predicted increase in slope for the sales data. So what does the slope of this line mean? Which is 23.28, and so that means that's the average increase over time each year for the sales data. So it looks like it's $23.28 is our predicted average increase per year. All right, so over the 10-year data set, which we have, sales increased by the slope, which is 23.28. So sales increased by $23.28 per year on average. So that was the average increase per year for the sales data. Okay, so questions on this one, number 2. Anything for the absolute percentage errors, the predictions, the interpretations of the linear slope. Okay, so any more questions on the review problem here, or what to expect on the upcoming midterm? Okay, so just a few more things, and looks like we'll finish a little bit early today because I just wanted to go over the review for the midterm too. And so, okay, so a few things I wrote in the chat. So we went over the practice midterm, which was that one, and you have my solutions you can study for. And so I'm going to pass out midterm 2, or distribute midterm 2, post it on Blackboard next Monday, April 20th. And it's going to be due in a week. It shouldn't take you that long. It shouldn't take you more than like a normal midterm of like 1 or 2 hours. But you have time to do that, so make sure you finish it within a week. It's going to be due April 27th. Okay? And then like I said here, any assignments that the students have not turned in since spring break, since we became online only, for this portion, those have to be submitted by the same day as the due date of the midterm, which is April 27th. So that means all of these right here, you see. Example 4.5, the drug production. Example 4.8, example 5.4, example 5.6, example 5.7, example 14.1. So most of you, well, this one's not due until Monday, but by Monday, most of you have done all of these. But if you haven't, if you missed one, and you want to do it, you still have a little bit more time to do it. But the final date that I can submit those is, or I can take those, is April 27th, because I'm going to post the solutions and for the midterm and all the practice for the assignments. And so once the solutions go up on Blackboard, then you can't submit any more late assignments. So if you want to submit any of the ones if you've missed any and still want to put those in, you've got a little bit more time. And midterm 2 is going to be distributed on Monday, April 20th. And you're going to email me your answer sheet. And like I said here, if you could do a PDF document or a Word document, that's preferred. If you can't do that, then just let me know and we can work something else out. And that's all I wanted to tell you for today. So, if you have any more questions about the upcoming midterm or any missed assignments, please let me know. If not, you're free to go and come back on Monday where I'll give you guys and explain the midterm. And as always, thanks for coming and please stay safe and have a good weekend.